The supply function. The supply function shows the correspondence between the quantity supplied, price, and other factors that influence the number of units offered for sale. Written generally without specifying the functional form, the processed pork supply function is capital Q equals capital S of P and B sub N, equation 2.5, where capital Q is the quantity of pork processed supplied per year, P is the price of processed pork per kilogram, and P sub B is the price of hogs. Excuse me, that is P sub H. P sub H is the price of hogs, the major input used to produce processed pork. Therefore, equation 2.5 is capital Q equals capital S of P and P sub H. The supply function in equation 2.5 may be a function of other factors, such as wages as well. By leaving out these other factors, we are implicitly holding them constant, based on Moschini and Mühlke 1992. The linear pork supply function in Canada is capital Q equals 178 plus 40p minus 60p sub h, equation 2.6, where the quantity is in millions of kilograms of processed pork per year, and the prices are in Canadian dollars per kilogram of processed pork. If we hold the price of hogs fixed at its typical value of $1.50 per kilogram, we can rewrite the supply function in equation 2.6 as superscript 7. It reads, if P sub H equals $1.50, then equation 2.6 is capital Q equals 178 plus 40p minus 60p sub H equals 178 plus 40p minus open parentheses 60 times 1.5 close parentheses equals 88 plus 40p. Capital Q equals 88 plus 40p, equation 2.7. Because we hold fixed other variables that may affect the quantity supplied, such as costs and government rules, the supply function concisely answers the question, what happens to the quantity supplied as the price changes, holding all other factors constant? Corresponding to the supply function is a supply curve, which shows the quantity supplied at each possible price, holding constant the other factors that influence a firm's decisions. Figure 2.3 shows the supply curve, capital S superscript 1, for processed pork that corresponds to the supply function, equation 2.7. Because the supply function is linear, the corresponding supply curve is a straight line. As the price of processed pork increases from $3.30 to $5.30, holding other factors constant, the price of hogs constant, the quantity of pork supplied increases from 220 to 300 million kilograms per year, which is a movement along the supply curve. Figure 2.3, a supply curve. The estimated supply curve, capital S superscript 1, for processed pork in Canada, Moschini and Mühlke 1992 show the relationship between the quantity supplied per year and the price per kilogram, holding input prices and other factors that influence supply constant. The upward slope of this supply curve indicates that firms supply more of this good when its price is high and less when the price is low. An increase in the price of pork causes a movement along the supply curve, resulting in a larger quantity of pork supplied. We are given a graph, price in dollars per kilogram, vertical axis, capital Q, millions of kilograms pork, horizontal axis. We have an upward sloping supply curve. When the price is $3.30, 220 million kilograms of pork per year is demanded, and when the price is $5.30, there's 300 million kilograms of pork per year demanded. How much does an increase in the price affect the quantity supplied? By differentiating the supply function, equation 2.7, with respect to price, we find that d capital Q over dP equals 40, as this derivative is not a function of P. It holds for all price changes, both small and large. It shows that the quantity supplied increases by 40 units for each $1 increase in price. Because the derivative is positive, the supply curve, capital S superscript 1, slopes upward in figure 2.3. Although the law of demand requires that the demand curve slope upward, there is no law of supply that requires the market supply curve to have a particular slope. The market supply curve can be upward sloping, vertical, horizontal, or downward sloping. A change in a factor other than a product's price causes a shift of the supply curve. If the price of hogs increases by 25 cents, the supply function becomes capital Q equals 73 plus 40p, equation 2.8. By comparing this supply function to the original one in equation 2.7, capital Q equals 88 plus 40p, we see that the supply curve, capital S superscript 1, shifts 15 units to the left to capital S superscript 2 in figure 2.4. Alternatively, we can determine how far the supply curve shifts by partially differentiating the supply function, equation 2.6, with respect to the price of hogs, italics d capital Q over italics p sub h equals negative 60. This partial derivative holds for all values of p sub h and hence for both small and large changes in p sub h. Thus, a 25-cent increase in the price of hogs causes a 60 times 0.25. I'll repeat this sentence. Thus, a 25-cent increase in the price of hogs causes a negative 60 times 0.25 equals negative 15 units change in the quantity of pork supplied at any price of pork. Again, it is important to distinguish between a movement along a supply curve and a shift of the supply curve. When the price of pork changes, the change in the quantity supplied reflects a movement along the supply curve. When costs, government rules, or other variables that affect supply change, the entire supply curve shifts.